Hi, welcome back to the channel. In today's lesson, we will see the resistance and resistivity of a material. We will see how resistance relates with resistivity. I will use two examples to show you how to solve problems relating to resistance and resistivity. At the end of the lesson, we will leave you with a take-home example which you can practice on. I will be glad if you will share your result with us via the comment section. That said, let's get started. Now let's consider these two volumes. Let's label this A, while I've already labeled this B. Now, if I have the same volume of water flowing through A and also through B, you observe that the resistance of water flowing through A will actually be lower than the resistance of the water flowing through B. Why? Because of the cross-sectional area. That is, the wider the cross-sectional area, the lower the resistance of that material to the free flow of water. Same thing applies in electricity. The wider the cross-sectional area of the cable, the lower the resistance of that material. The other thing to be considered is the length of the material. Now, the resistance of any material is directly proportional to the length. The longer the length, the higher the resistance. The shorter the length, the smaller the resistance. So we can put both of them together to say that the resistance of any material is directly proportional to length over area. Now we're going to consider the proportionality of this equation. That is the resistivity of this material. So that we'll say that R now is the same thing as rho L over A, where rho becomes our constant of proportionality and is the same thing as the resistivity of this material. Now, this resistivity, we have agreed that is going to depend on the temperature, is going to depend on the conductor's length, the cross-sectional area, and also the type of material. Let's see some questions as practice examples. Now, my first question says the resistance of a 5-meter length of wire is 600 ohms. Determine the resistance of an 8-meter length of the same wire. Now, to determine the resistance of an 8-meter length of the same wire, the first thing we should remember is that our R, which is the resistance of the wire, is equal to its resistivity, the length over the area. Now, so that the resistance is 600 ohms, that is, my 600 ohms will be the same thing as the resistivity of the material times the length, which is 5 meters, over the area. Since we're going to look for the resistance of the same type of wire, that means the resistivity of the material will be the same thing, and the cross-sectional area will be the same thing. So I can simply make the resistivity of this material the subject of formula. So let's do that. So to make rho the subject of the formula, I'll say 600 times A, that's cross multiplying, divided by 5 is equals to rho. So that 5 here is 1, 5 in 600, that's 120. In case you miss our lesson on how to change subject of formula, please do not hesitate to check here on the link. We'll place a link here for you to access our lesson on how to change subject of formula. So that rho from here, which is the resistivity of this material, will be given as 120 A. Now, question A says we should look for the resistance of that material when it is 8 meters. That means R now will be equals to rho, which is 120 times area times L. The length now is 8 meters over area again. Now, because the same cross-sectional area will cancel A. Now, I'm left with R, which is equals to 120 times 8. That's the same thing as 960 ohms. That's 960 ohms. The second part of the question says we should find the length of the wire when the resistance of this wire is 420. Now, we're still going to apply our change of subject formula. Now, we're interested in length. From R from length now will be equals to R times A over rho. Now that is equals to R. My R obviously is when the resistance is 420 ohms. That's 420 times a cross-sectional area A, and our rho, the resistivity of the material, we already know is what? Is 120 A. So A cancels A once again, and I have 120, 420 over 120, 0 is cancelling 0. 6 in 12, that's 2. 6 in 42, that's 7. So that the length of this material will be given as 7 over 2, which is equal to 3.5 meters. That's 3.5. Let's take a look at the second question. Our second question says a piece of wire of cross-sectional area of 2 meters, 2 millimeter squared. That means A in this case will be given to be 2 millimeter squared, and the resistance of R will be given to be 300 ohms. Find a resistance of wire of the same length and material if the cross-sectional area is, the new cross-sectional area A2, let's call this A2, is given as 5 mm squared. Now we should find the resistance R2. That's what we're interested in. Now from our formula says that our R is the same thing as rho times length over area. So that we'll be saying that my A, from the formula, we'll be saying that 300 is the same thing as rho times 2 times L over 2. In this case, we're working with a material of the same length. So we could put both length and resistivity together. So that both length, rho times length, is the same thing as 2 times 300. That's equals to 600. Now, so that we're to solve for the resistance of this material, let's do a change of subject formula. The resistance of the material, R, is the same thing as rho times length is 600 over A, that's 5, which is equals to 120 ohms. That's very easy, 120 ohms. Now let's take the second question. The second question says we should find a cross-sectional area of the same length and material of resistance 750. Now in this case, we're already given for the second question, we're given our resistance to be 750 to be the same thing as, already we have rho times, that's rho times length as 600, that's 600 over the same length. We should find the cross-sectional area over A. So we're interested in the cross-sectional area. So that will be, we'll cross multiply, that will be 750. A this time around will be the same thing as 600 over 750. Now you can use your calculator to quickly solve that. Now 600 divided by 750, that's the same thing as 0.8. Now the area in this question is given as millimeter squared. So I have it as 0.8 millimeter squared. Thank you for staying with us. Like I promised at the beginning, that I will leave you with a work example. Now you can take this question and try your hand on this question. In case you're yet to subscribe to our channel, please do not hesitate to hit the subscribe button. That is one way to tell YouTube you love what we're doing and also to encourage us to do more. Thank you for staying with us and see you in our next class.